Western Canada has been experiencing some of the world's most rapid environmental and climatic change. By developing new cutting-edge science and modelling tools, the Changing Cold Regions Network is better prepared to predict the future of this changing environment. Taking what we've learned from the past, as well as from recent extremes of flood, drought and fire, we're able to make more advanced predictions. We hope that these will enable society to better manage the water needs of future agriculture, industry and communities while protecting our fragile ecosystems, and better managing risk from the more damaging extreme events that we predict will occur in the future.
We use high-resolution atmospheric models such as WRF to help us better understand the future climate. With 4-kilometer resolution, we're able to simulate the convection explicitly and the formation of the precipitation in a more realistic way. We are going to see a continuous warming across much of Western Canada through the 21st century. The seasonal average temperature increase could be up to 10 degrees C for the northern area. This warming is expected to be higher in northern Canada, with the largest temperature increases continuing to happen during the winter months. The summer months will see a lower rate of warming of 4 to 6 degrees C. Overall, our models suggest that we'll see a slightly increase in precipitation across the whole domain, with the highest increases happening during the fall and the winter months, and with higher increases in the north. Our models also suggest that we'll likely have an increase in precipitation extremes. Because of the higher temperatures and more water vapor held in the atmosphere, we'll experience more convective precipitation events, such as thunderstorms, which can bring more intensity rainfalls and hail. Other extreme precipitation events, like droughts, will also increase in frequency and not only just impact the agriculture sector, but may also lead to extreme fire years like we recently experienced across the Western Province and the territories from 2014 to 2017.
Climate is changing, and as it continues to change over the 21st century, the warming temperatures, longer growing seasons, and increases in plant water stress are expected to drive big shifts in vegetation across Western Canada, with prairie crop and grassland expanding northward into the southern boreal forest, deciduous trees replacing evergreens in parts of the central and northern boreal forest, and shrubs encroaching on tundra to the north. Some of the changes in vegetation, like the expansion of shrubs above the northern and alpine tree lines, will occur in response to climate change alone. Other vegetation changes will occur only after wildfire. In these cases, the impact of climate warming will be twofold. First, increasing the frequency and intensity of fire, which triggers change, and secondly, causing a loss of ecosystem resilience, so that after burning, a forest in the south may be replaced by shrubland or grassland, and an evergreen forest in the central boreal may come back as deciduous forest or mixed wood. In addition, there's a real possibility that northern evergreen forests growing on peaty soils will collapse as the permafrost melts, to be replaced by wetlands. These vegetation shifts, together with the melting of permafrost and the recession of glaciers, will have profound impacts on regional ecology and surface water resources, impacts that are perhaps as great as those of climate change itself.
We, interestingly, will still have a full winter in the alpine in this area, but at the lower elevations around it, the snow cover in the winter might be more ephemeral. It would be coming and going various times. We can expect rain any month of the year, temperatures above freezing any month of the year in the alpine, but still a spring snowmelt, though I'd expect it to be approximately a month and a half to 2 months earlier. We'll also experience extreme droughts in the forests and in the alpine regions, and probably more fires. So perhaps on the mountain slopes, reduced forest cover because of fire and expansion of grassland in the valley bottoms could well happen.
Growing crops on the prairies requires a balance, not just a balance in terms of having not too much moisture or too little moisture, but also having the moisture timed in a way that the crop can mature and the farmers can harvest the crop and get it off without damage. Well, an increase in temperature can lengthen the growing season and create more heat, particularly in some of the northern areas, and perhaps open some of those areas up for the types of crops that we're growing now, or in some of the areas where we currently are cultivating land, we can open up to a wider variety of crops. The concern, though, is that higher temperatures are going to create higher evapotranspiration, and this is going to mean that we will likely lose moisture faster over the course of the growing season. We expect that there's going to be lower snow cover on the prairies, lower snowpack in the mountains, and higher temperatures throughout the growing season and over winter. What this can mean is potentially lower flows for water, which could impact irrigation. It could mean lower soil moisture conditions in the spring, which could implicate the moisture availability for crops during the growing season. And the warmer temperatures could result in higher incidences of heat stress and create more favorable environments for pests.
So there's quite a few compensating factors when looking at these large river basins. They tend to integrate what we see with respect to the hydrological cycle. And so sometimes what you see is a small change perhaps in flow at the mouth of a very large river like the Mackenzie, but a lot of changes internally to the basin. However, we are seeing changes in the timing of flows, and that's pretty evident in most basins where we're seeing the peak flows occurring early in the summer, and we're also seeing in places like Saskatchewan longer duration of flow in the summer season, which we haven't seen before. That's certainly being predicted by the models for the future. It'll be interesting to see how we actually deal with that down the road, but for now, that's one of the big outcomes we're seeing. The other thing we're seeing is increased precipitation, particularly in the eastern prairies. We've had some significant events. These events we haven't seen historically, so we're noting with the models that the likelihood of those significant precipitation events in the late summer is likely going to increase. But of course, there's a lot of variability with flow on a year-to-year basis. So in a year where there's heavy snowpacks, there's still going to be high flows, and we're seeing actually a likely increase in extremes. So we think the drought periods are going to get longer, and we think the flood periods will be more frequent, and that seems to be appearing in the model.
Our early model outputs are suggesting that we will start to sort of cross a threshold of hydrological behavior in these cold mountain watersheds and northern watersheds. It will occur at the southern latitudes first and at the lower elevations first. We'll see a shift from a snowfall-dominated hydrological cycle to a rainfall runoff-dominated hydrological cycle. So in the last 4 years, we've seen the highest flows ever recorded and the driest droughts ever recorded. And it's that sequence of highs to lows, of extreme variability in the hydrology that may be the most difficult part to adapt to for Canadians in the Saskatchewan and Mackenzie River basins. We've improved our understanding of hydrological processes and the hydrological cycle in this cold region. We're taking that information and improving our models.
The rapid and extensive changes to water that we're seeing in Canada are mirrored throughout the world's cold regions, the Himalayas, Andes, Alps, Tibetan Plateau, and these supply water to half of the global population. These changes pose existential threats for society. We live in an ever-connected world where flood and droughts affect not only local populations, but national economies and global trade. This unprecedented change poses critical challenges to manage water security in a future that will always be uncertain, and for science to provide the information and tools needed to adapt to this change. We hope that CCRN's new data, science and models will make a difference, but this work must continue so that we can observe and better understand the implications of these remarkable changes and provide useful information for managers, policymakers and the public. And we will all have to do our part in managing and adapting to change and shaping our future in a warmer world.